we have in our next session, we have Professor Babusena Pal. Is Sir Babusena sir? Are you there?
Yeah, I am online.
Okay, sir. With us for session 10, we have Professor Babusena Pal. Professor Babusena Pal, whose topic is implementation of AI in next generation communication. Let me introduce him at first. He is the Associate Professor and Director of Institute of Intelligent System, University of Johannesburg, South Africa. He has total year of experience of 27 years. It is our privilege to have Dr. Babusena Pal. Welcome you again, sir. Dr. Babusena Pal received his BTech and MTech degree in radio physics and electronics from University of Calcutta in 1999 and 2003 respectively. He was he was with Philips India Limited from 1999 to 2000. From 2000 sorry, from 2000 to 2002, he served as a lecturer of Electronics and Communication Engineering Department of SMIT Sikkim. He received his PhD degree from Department of Electronics and Communication Engineering from IIT Guwahati. He has attended and published over 90 research papers in international and national conferences, symposiums, and peer-reviewed journals. He has successfully supervised several postgraduate students, doctoral and postdoctoral research fellows. He joined the University of Johannesburg in 2010. He was served as a head of the Department of Electrical and Electronics Engineering Technology, University of Johannesburg, from April 2015 to March 2018. He is currently serving as the director of the Institute of Intelligent System, University of Johannesburg. His research interest lies in data analytics, Internet of Things, artificial intelligence, machine learning, cyber physical systems, predictive maintenance, and other technologies of fourth industrial revolution. So I am handing over this session to Professor Babusena Pal sir. Sir, please, after you, sir.
No, thank you, Dr. Maiti, and good evening to all of you.
Good evening, sir.
So maybe I am the one who is between all of you and the beginning of the weekend. So having said that, let me start. Yeah. So maybe I'll switch off my camera for bandwidth and is it fine?
Yes, sir. It is visible.
Okay. Just give me a moment. I'll minimize. And Dr. Maiti, thank you once again for the kind introduction. At any point of time, if my voice is not audible or my slides are not being seen, then please do let me know.
Yes, yes, obviously.
And if needed, you can WhatsApp me also. Yeah.
Okay, sir.
So thank you and welcome to this talk. So today we'll be talking about an introduction to AI and communication. Basically, all the words are important over here. Two important words. One is AI, another is communication. And the third is that this is an introductory lecture for people, those who may be new to AI, for people who may be new to communication. So we will go through both the things. And then at the end, we will merge the AI and communication and see how it works. Yeah. So a brief outline of today's talk. So I will give you a brief introduction about my university and the institute, the Institute for Artificial Intelligence Systems. Then I will talk a few slides about why AI became a buzzword in the recent times. because maybe 10-15 years back also, AI was nowhere to be seen. When I completed my PhD, we never spoke in the lab about AI. But recently, AI has become a buzzword. And why has it become a buzzword? Because if you see that most of the algorithms, machine learning, deep learning, or neural nets, most of the algorithms are quite 50, 60 years old. But why suddenly? So that is another. Second, then we will talk a bit about communications, a few slides on communications. So we will talk about 6G also, how the architecture of the 6G is, what are the benefits of 6G, what we are looking at. Then after that, we will take you through a few algorithms of AI. Both from the basically we will be focusing more on the machine learning aspect. Then we will see the application of AI in communication, that is in 5G, how AI is being currently used. Yeah. And then we will map basically in our last slide, we will map the different algorithms and how communication is using the different algorithms. So having said that, so basically, University of Johannesburg was formed in 2005. So currently, we are in the 20th year after the convergence of 4-5 institutions, which already existed for more than 50, 60 years. And currently, we are having 4 main campuses in Johannesburg, Auckland Park, Bunting Road, Soweto. Soweto is one of the most important places in the struggle, apartheid struggle of South Africa. This is where President Nelson Mandela was used to live. So we have a campus there, and the other campus is the Dorenfontein campus. And we have a few satellite campuses, small campuses throughout the city in Johannesburg. We are having 8 faculties, basically the standard faculties which a university has. The current student strength is nearly 50,000 students. We offer, in all these faculties, we offer undergrad, postgrad, doctoral, postdoctoral. So it is a full-fledged. Apart from these 8 institutions, means 8 faculties, we have 5 flagship institutes. And out of these 5 flagship institutes, our institute, the Institute for Artificial Intelligence Systems, is one of the flagship institutes, which we started in 2019. Basically, it started in 2018, but the official launch happened in 2019. So in the first year, we were developing some products. So this is the picture that you are seeing is basically from the launch of the institute in 16 September 2019. And the main mandate of the Institute for AI Systems is basically to drive and coordinate all the 4 activities of the university. So that is our mandate. And we do offer masters in artificial intelligence, both taught and research masters. We have doctoral and postdoctoral students. We don't offer undergraduate curriculum in the institute. Now next, let us come to this, that why AI became a buzzword in the recent times. So if you look at the industrial revolution going, so in the first industrial revolution, it was basically steam powered. So now then came the second industrial revolution in the late 1800s. And the difference that happened is basically the steam power was replaced by electrical power. After that, the third industrial revolution came in the 1970s. where before this, basically in 1947, transistor was invented in the Bell Labs, and then computers came in. So that is one of the things that led to the third industrial revolution, the networking of computers. We had automation, we had electronics. So all these were happening in the third industrial revolution. So people say that in the present scenario, in the 2015s, 20s, 2020 somewhere, or in early 2010s, that is the time when we were moving to the industry 4.0 or the fourth industrial revolution. So basically, this revolution can be thought of as an extension of the third industrial revolution. And it is fed by the third industrial revolution. Yeah, so in this currently what we are seeing is cyber physical systems, Internet of Things, and networks. Yeah, and if all this you see is basically driven by AI, and we'll come to this one after a few slides. So, so currently we are in this fourth industrial revolution, and people do say that some of the pillars, but this is not an exhaustive one or a comprehensive one. So some of the pillars are big data, cloud computing, 3D printing, cyber security, and all this. Autonomous robots are there. So these are the pillars of the fourth industrial revolution. And if you have a closer look at these pillars of the fourth industrial revolution, basically you will see that all these pillars basically is like a garland where all the flowers relate to data in some way or the other. Basically, when we say IoT, Internet of Things, we are talking about basically collecting our data using sensors. When we talk about big data, it is basically collecting, processing, wrangling of huge amount of data. When we are talking about cloud computing, we are basically talking about processing data. So we can see that there is a thread of data which goes from the full in all these pillars. Now, where is this data coming from and why suddenly? So this is a study done by Oros in 2015. So it is basically a 10-year-old study, but it gives a very beautiful insight. So in this study, Oros says that 90% of the data in the world in 2015, that means the 90% of the data that was present in the world in 2015, 90% was created in 2013 and 14. So 90% of the data in the world in 2015 was created just in 2013 and 14. So you can understand from the beginning of the digitalization, digital revolution and all those, the huge amount of data that was being created. Yeah, the rate at which the data growth is happening. Yeah, so it is very, very fast growth. This same study says that the data growth is expected to be at 40% per year. So if the data growth is happening at 40% per year, then you can understand that what is the level of data or how much data is being now present in the world, that is the data sphere. Yeah. Now the question is, when we talk about AI, ML and all this, now all these things were already there for 50 years. Yeah. Now this huge amount of data needs to be processed. Now the processing of the data, that was basically a problem. That was very, very costly. Maybe 20 years back also, we did not hear about cloud computing or data lakes. Yeah. So these are some of the things that are happening recently, some 7, 10, 12 years back, that cloud computing has come in, data lakes have come in. Now these data lakes and cloud computing coming in has reduced the cost of processing the data. So once the cost of processing the data has reduced, now the huge data that was present, people started processing those huge data using the algorithms which were already present. Because otherwise we needed a mainframe or a hypercomputer, to process it, which was costly. But now the cost has gone down. A similar story or a study shows, this is done by IDC's Data Age. Huh? This shows that the exponential growth of data that is happening currently, that is in 2025, this study in 2017 predicted that we will be having 163 zettabytes of data in the world. This includes all types of data. Zettabytes basically means trillions of gigabytes. Means not trillions of, but trillion gigabytes. Yeah. So you can understand the amount of data that we are having. In a recent, maybe a week or so back, you might have seen it in the news, that the UK government is asking its people to delete the old emails and images and or old data that is being present. Because keeping this data, huge amount of data, means old emails, images, photos and all this, that requires data centers. Now the data centers needs to be cooled. Now it is, the water is a big problem because mostly they are water cooled, and so water is a big problem currently in UK. So they have asked, they have made an appeal. So you can understand that the huge amount of data that is being there. So now we understand that why AI has become popular recently. So next we come to the mobile communication. So in the mobile communication, just for completeness, so we have now currently in the 5G, we are expected to be in the 6G by 2030. So we started in 1980s with the 1G, the analog one, which was invented or developed in the Bell Labs. And later it was improved in collaboration of Bell Labs and Motorola, called the AMPS. That time they named it the Advanced Mobile Phone System. So now today, if anyone says that it is advanced, people will laugh. So it was basically a 850 megahertz cellular band that was there. Then within 10 years, we moved to the in 1990s to the second generation. The thing that happened is that previously in the first generation it was only voice. Now voice and text can be done. The data rate has improved to 50 kbps. The latency has reduced. So this we called it as GSM. That is the global the system for mobile communications, or the GPRS, that is the General Packet Radio Service. So after this, in 2000s, we moved to the 3G. So again, you see, in 10 years, we are shifting, we are changing the technology every 10 years. So within 10 years, we shifted to 3G. And we were, this is the UMTS system, the Universal Mobile Telecommunication System. Now with higher data rates, so we now move to Mbps range. The latency has reduced. So you will feel more like true communication. Now in this third generation, we basically added another dimension to the thing. That is, we started multimedia also, that is live video streaming. So then we come to the 4G communication, that is what we call the long-term evolution. Again, the data rates were increasing. Now in 2020s, currently we all have 5G communication, data rates at Gbps, somewhere they call 10 Gbps as the 5G, somewhere it is 20 Gbps, depending on countries. They have made it the 5G data throughput. The latency has also reduced, and the mobility now we can communicate at a high, much higher the speed also. That is, you can be on the move at 500 kilometers per hour also, and you can communicate. Now, before this, in the 4G, when we were doing, it was voice, mobile communication, internet, and all this. But now, it is more data that is coming in. So it is now IoT, wearable devices. So all these are connecting over the internet. Then smart cities. Yeah. And what we are means what the researchers predict that by 2030 6G will be ready at a data rate of more than 1 Tbps. Yeah. Now with a latency of 10 to 100 microseconds. Now with a mobility of more than 1000 kilometers per hour. So 1000 kilometers per hour is a huge mobility. Yeah. Now, why do we need basically this kind of 6G at such a high data rate? The reason is basically we would like to combine everything. That is the land, the space, the sky, the ocean. So all the communication, so that from anywhere communication is possible. Because you have seen that space tourism has already started. So if space tourism has started, then the communication with the space is needed. Yeah. So that is why in 6G we need high data rates and latency. Moreover, nowadays in the medical field also remote surgery and all these things are coming in. So for that also low latency is needed. We have moved to autonomous vehicles. So for that also real-time, low latency, high data rate is needed. So that is what we are expecting a much smoother operations in the 6G. Now this is the architecture of the 6G architecture. So basically in the user end you have the cellular network, the common cellular network with the macro base stations that we have. You have the vehicular network with the roadside units, the small base stations, the vehicles, communication between the vehicles happening. And you have the heterogeneous networks. That is the different types of networks, that is femtocells, picocells, you have your Wi-Fi. And the intention is basically that there is a seamless connectivity happening within the heterogeneous network. Now, to do this and to process the data, we have a H-plane. That is, if there is immediate processing needed of the data, and if the data is not of a huge amount, then we do it at the H-plane. And the next higher plane is basically the cloud plane, where the processing happens. So basically in all these planes, there is the use of artificial intelligence happening. Now this is the other 6G architecture from the point of view that what do we see and where do we see to that 6G will be used. So one is in the satellite internet. So we are seeing that 6G will be used. So there will be space routers happening. Another in the ocean communication, we are seeing that 6G will be used. We have space routers over here for routing from the space, that is. And again, we have on the ground, we have our remote area communications, we have our IoTs, we have our smart cities, we have our sky, that is the airplane coverage. So in the terahertz range. So this is basically communicating or bringing everything together, be it land, be it sky, or be it space. Now the applications of 6G, when we come to the applications of 6G, we have the mobile broadband, but this is an enhanced mobile broadband basically, because we are using smart glasses, we are using wearable devices, we are using smart headphones, so all interconnected. So this is where 6G is coming, will play a big role. Currently we do have use all this, but the experience will be much better. Then we have big communications, that is the swarm of drones communicating with each other. airplanes communicating with each other, trains communicating with each other. So these are in the big communications that we are having. Then we have the SURLC, that is the super ultra reliable low latency communication. So in this, basically your robotics, your automation, all this comes into play. So your regular communications comes into play. Your smart TVs, your smart cameras, all this comes under the low latency. Then comes the ultra critical data communication. So this will also be supported by the 6G. So this is ultra critical in the sense, for example, when you are doing smart surgery and things like that, or let us say you are using autonomous vehicle. So these are basically critical data communication. Yeah. And then we have the 3D integrated communication. So the integration of all this, that is the land, the air, the space, and everything integrated together. So now that we have an idea of 6G communication, what we are looking for, which is an extension of 5G and bringing everything together, next we come to artificial intelligence. Now, artificial intelligence, people define it in different ways. For example, you might have seen this standard figure that machine learning is a subset of artificial intelligence. Neural network is a subset of machine learning and deep learning and so on. Some people do consider data analytics also to be a superset that is above this one. They consider this one as data analytics and data analytics and artificial intelligence as a subset of data analytics. So we have basically neural nets. Nowadays we are having deep neural nets also. Basically a simple neural net is basically one with one or two hidden layers. If the number of hidden layers goes on increasing, then we call it a deep neural net. So that is the different. And then in the deep neural net also we have different types of deep neural nets. The CNNs we have, the RN we have. Yeah. Now, this is another figure and which is more relevant in today's world, because now when we talk about conversational AI, that is when you are basically conversing with a machine. With the advancement in the LLMs, that is the large language models, I think today, in today's world, maybe the previous figure was very good 3-4 years back also, but in today's world this figure is more apt because the LLMs have already come in, which leads to the conversational AI, that is our chatbots, our chat GPTs and things like that, and which uses natural language processing also. But whereas the other end remains the same as the previous slide. Yeah. Now, let us come to the machine learning portion. So there are basically machine learning is divided into three parts: supervised, unsupervised, and reinforcement learning. So supervised basically when you have labeled data, unsupervised when you have unlabeled data, and reinforcement learning is basically when you train the machine learning algorithm by rewarding the algorithm when it does correct, or by punishing the algorithm. So the algorithm learns on its own. Yeah. So in unsupervised, we have association and clustering. So I'll fly through these slides basically. So in association, basically, this is a kind of unsupervised algorithm which is done in market basket analysis and things like that, where you see, for example, in a shop, like big shops, how will you arrange the shelves? What will you keep next to each other? Will you keep let us say the bread and the milk milk next to each other, or will you keep the bread and the chocolate next to each other so that it gives a better experience? So this is what association kind does, that how closely two elements, three elements are related. The other is the clustering algorithm, which is commonly used, and we do use it in communication also. We will go through a few clustering algorithms and give you a visualization of how the clustering algorithms work. So clustering basically means grouping of data points into specific groups. So you are having, let us say, a huge amount of data points. So your aim is basically to group these data points together into a specific number of groups, or the data should be able to say that how many number of groups is optimum or the best in the data that you are having. Now, why do you want to do that? The reason for doing that is that because the data in the same group will be having the same properties. So basically you group the data in such a way that the data are expected to have the same properties in the same group. Now there are different clustering algorithms. For example, we have the k-means clustering algorithm. Now in the k-means clustering algorithm, this is basically an heuristic algorithm. If we do clustering of data points, let us say we have some huge number of data points. Just give me a moment. Let me check. Let us say we have a huge number of data points and we want to cluster together. Yeah. This is basically heuristic. The reason for saying heuristic is that after doing the clustering, you may get a different cluster from what I get. So that is possible, and that is totally right. So basically, what this algorithm does is first, you need to say that how many clusters are there, or how many clusters do you want to break the data point into. So let us say we say that we want to break the data point into two clusters. So then we take two arbitrary data points, saying that these are the centers of the two clusters, and we take this arbitrarily. And then we find that what is the distance of the data points from these two centers that we have chosen. And then if it is close to these centers, then we say that it belongs to cluster 1 or it belongs to cluster 2. Then once we have done that, then we forget about the center we have taken. We take all the points that we have found out that are closer to cluster 1 or that form part of cluster 1. We take all those points and find the center based on those points. So if these are the points which are in the first iteration, if these are the points which came to be cluster 1, then once these points have been come into cluster 1, we forget this center, we take these data points and we find the center of these data points. So this is basically another new center that similarly we do for the second one also, and we find the new center. And then again we repeat the same thing with the data points. And this iteration goes on till the time that the centers do not change their points. Means the centers do not change in the nth iteration and the n plus 1th iteration. If the centers remains the same, then we say that we have formed the cluster. So one of the problem in this is that we have to say that how many clusters we need to have the data, means we want the data to be divided into how many clusters. There are some algorithms, for example, we have algorithms like elbow methods. We have algorithms like silhouette plots. Yeah, to find out the optimum number of clusters that are in the data. In the elbow methods and silhouette plots, what we do is that we run this algorithm for 1 cluster, 2 cluster, 3 cluster, let us say 10, 15 clusters. And then after that, we see that what is the best number of clusters that the data is having. So this is one of the biggest disadvantages of this k-means algorithm. So over here, we are basically showing you a visualization of this algorithm. So what you are seeing on this top is basically the iterations. And you will see 3 crosses in the box, in this square box. And these 3 crosses are moving. So with each iterations, the initial centers are moving and then they are converging. Yeah, when once they converge and the centers do not move, then we say that these are the clusters. So the basic disadvantage is that the algorithm does not itself say that what is the best number of clusters in this data. Now to do this one, what comes that so that the algorithm gives you the best number of clusters, we come to the mean shift clustering. So this is basically an hierarchical clustering. So this clustering is basically the mean shift clustering is a hill climbing kind of an algorithm. Now, why it is hill climbing kind of an algorithm? Let me explain it a bit with an analogy. Let us say there is a hill and there are 100 blind people at the bottom of the hill. Now, these 100 blind people at the bottom of the hill needs to reach the top of the hill, and they don't know how they will reach the top of the hill. Yeah, because they cannot see where the top is. So let us say the blind people are told that you give your next step, and if you gain in altitude, then you go to the next step and give the next step and see if you are gaining in altitude. If you are not gaining in altitude, then stop. So you can understand that if there are 100 people at the base of the hill, there is a likelihood that there will be a few people who will reach the top of the hill, isn't it? Now let us say if there are, instead of one hill, there are 5 hills like this. Yeah. And instead of this, you are scattering these 100 people or 500 people all around, or 5,000 people, blind people all around these 5 hills, and you teach them the same thing, or you give them the same instruction that you give a step, see that if you are gaining in altitude, then go forward and go to the step and place your next step. If you are seeing that you are not gaining in altitude, then you stop. So if you do this one, then in all the hilltops there will be people who will be reaching, isn't it? So this algorithm is also basically similar. So when there are multiple hills, then you need more number of people, isn't it, to do this one. So what it basically does is this algorithm starts with a circular sliding window of radius r, and it sees and it goes on moving. Now if the number of data points in this window goes on increasing, that it goes on moving towards the number of data points till it reaches the maximum data point. After that, if the number of data points goes less, then it stops. Fine. So basically the centers are calculated. Once a circular window is made, seen that how many data points are there. After that, from that data points, the center is recalculated and the circle moves. Now again it is seen that how many data points are there. So in this way, if the data points are more than the previous one, it goes to the next step. Or if the data points are not more, then it stops. So this is how it is done. So if you visualize it, then it will be much easier. So you see that these are the number of iterations that are happening. That is, with the number of iterations, the number of points are going on increasing. So you are calculating the centers, new centers, and the data points are increasing. So you are seeing that the data points are going, and when it goes to 152, and then it comes down to 151, so it stops. Now with this data point, with one circular window, you are moving. But if there are multiple clusters and multiple, then what you do, you start with multiple windows. Now you see these points that you are seeing, the dark dots. I think you are able to see the dark dots. Then what will happen? These multiple data points will be converging at the centers of the multiple clusters. And once these circular windows converge, then it will say that this is one of the cluster, this is one of the clusters. So this is what the advantage is, that you don't have to say that how many clusters are there. So with the iterations, the windows do converge at the different, because the windows are started with all over. Same like as the analogy, the blind people are scattered all around. So some will go to the top of this, that is the high density region. Some will go to the top of this, and some will to the other clusters, the top of the other clusters. Yeah. Now there is another. Now the problem is of this things is that if the data points are not in the way, because see, when you are seeing these data points, you can visualize and say that this is one cluster, this is one cluster, this is one cluster, and this is one cluster. Yeah, but if the data points are not in this form, but if there is a pattern in the data point, then how do we do it? For example, let us say that there is a pattern in the data point like this. The data points are in a circle like this. So these are all the data points. So it is a pattern, isn't it? So how do I cluster? So now my cluster should be that all these are in one cluster. So this is in one cluster, isn't it? If you go by this kind of algorithms, that are hierarchical algorithms, then you will end up in saying that this is one data point, this is another data point, and this is another, and so on. Fine. So that is where the DB scan comes in. That is density-based spatial clustering with application of noise. Because when the noise is, there is noise in the data, there are outliers in the data. Now in this algorithm, I am not going point by point, but there are two parameters. One is called the epsilon, the parameter, and the other is called the minimum number of points. So what does epsilon mean? One data point and one data point. If the distance between these two data points is less than epsilon, if the distance is less than epsilon, then we say that these are neighbors. Fine. Now, what is the other parameter? The other parameter is that in a circle which is of epsilon diameter, that is, and if there is a minimum number of points, so we will be defining this minimum number of points. Let us say there are 4. We define minimum number of points as 4. Then in this, if there are more than 4 data points in this circle, then we consider this as a closed cluster region. Fine. Now, if you see the visualization, you will be understanding and how it is removing the outliers or the noise in the data. Means we can call it noise or outliers also. So you see, so these are the circles going. And I have said that the epsilon is 1 and the minimum number of points. So in a circle of radius 1, if there are 4 points, then I go to the next point and say that that is part of the cluster. So in this way, you see that this algorithm, basically the DB scan algorithm, clusters the data into this as one cluster, this as one cluster, this as one cluster, and the outside as one cluster. And at the same time, it says that this is noise and this is noise. The reason for saying all these points noise, because if you draw a unit circle, there are no 4 data points inside it. And these are the 2 tuning parameters of the algorithm. And you basically set the tuning parameters depending on the data type that you are having. Next, we come to supervised algorithm, that is where you have labeled data. So regressions, classifications, we will not talk about regressions, but we will talk about classification. Now, one is KNN, very commonly used classification algorithm, but for high dimensional data, it is a bit difficult to use KNN because it becomes computationally intensive. So, what does KNN stand for? KNN stand for K nearest neighbor. So, if you talk about the philosophy of this algorithm, the philosophy of an algorithm is that you know a person by the association he keeps. Basically saying that let us say I as a person, you can know a lot about me if you know my friends. And the question is, how many friends would you want to know about me? Because I am having 100 friends. Out of this, some are distant, not very close to me, some are very close to me, some are in the mid range. So if I say that this is me, and if I try to plot it, so there is friend number 1 who is very close, there is friend number 2 who is also close, friend number 3 close, friend number 4, like this, friend number 5. So if you know about a group of friends which are close to me, then you will get to know my characteristics also. So in this KNN algorithm, basically a supervised algorithm, it is labeled data, so you know the target function. So that means you know the characteristics, the one that you want to find for me. So it is mainly a classification algorithm, and the philosophy is that it classifies data based on how its neighbors are classified. Now the question is that how will you classify? Or how many friends will you take to know about me? So if I have, the rule of thumb is that if there are n number of friends, then it is better that you take root over of n. Now if there are even number of classes, then you take root over of n plus minus 1. Or if there are odd number of classes, then you can take root over of n. So basically after that you weigh that what are the friends or the nearest people are like. And then from there you get to know about me. So this is basically the KNN algorithm. Then we have support vector machines, very commonly used. So this is a classification algorithm again. So you have, let us say, data points. I'm showing it in 2D, so it can be extended to 3D, 4D, and other higher dimensions also. So basically in this one, you are having red balls and yellow squares. So let us say you have an unknown data coming in, which is a triangle. So now you will have to classify it into red balls or yellow squares. So what do I call this one? Do I call this one red ball or yellow square? So for doing that, I need to divide the space into two parts. The one side should be red balls and the other side should be yellow squares. But dividing this space, I can do it like this. Then it comes as yellow, red ball. I will label it as the triangle. Or I can do it like this also. I can divide the space, or I can divide the space. So basically on how you divide the space, you will be labeling the data. So what is the best way to divide the space? So that is what comes from the support vector machine. So in the support vector machine, basically you are trying to divide the space where the vectors are basically the data points. You are drawing a line in such a way that the space between these two dotted lines is maximized. Fine, these two dotted lines is maximized. And these dotted lines are drawn in such a way that they touch the vectors of the two classes. Yeah. So this is touching the vector. This is called the support vector. Because this is supporting this line and this is also touching the vector, touching the dotted line. So this is called the support vector. So this is basically this support vector machine. This is basically the best line that you can draw. And once you have drawn, then you classify any unknown data. Yeah, and this is done used in the AI communications also. We will see after a few slides. Now next we come to deep learning. So basically you have seen the learning models, the network, the neural nets. You have your input layer, you have your hidden layer, and you have your output layer. But when the hidden layer, number of hidden layers goes on increasing, means more than 3, 4 hidden layers, you call it to be deep learning. Yeah, but with increasing the number of hidden layers, you are basically increasing the need for computational capability. And in the deep learning models, there are different models. For example, CNNs, convolutional neural network, recurrent neural network. Yeah, then you have CRN also. It is not over here. The convolutional recurrent neural network. Yeah, you have the adversarial networks. You have LSTMs. So there are different, and these are used for different types of purposes. For example, long short-term memory networks. For time dependent data, for time series analysis and things like that, we use it. Now next we come to the next part, that is the AI in communication. Now the AI in the telecom industries are used basically, but this is not limited to this one. One is for network optimization. The other is for mobile tower operation optimization. For example, predictive maintenance is used for mobile tower operation optimization. Fine. Then virtual assistance, fraud detection, the AI is being used, and predictive maintenance is also used for AI. Fine. To get a more view or more understanding, so it is used for network slicing. So we will talk about only one or two of this one. Yeah. So we talk about network slicing. Then for spectrum management it is used, traffic management it is used, traffic forecasting it is used, predictive maintenance I have already said, energy optimization, yeah. Then there are resource allocation, that is power allocation, bandwidth allocation, spectrum allocation, intrusion detection. If there is any anomaly happening in the network, load balancing and things like that, that also AI is being used. Now, before we go to network slicing, understanding network slicing, I would like to see, draw an analogy. Basically, in communication, you are basically trying to reach from one place to another, the data from one place to another. Yeah. So the data may be voice data, the data may be, there are lots of people over here, some trying to send voice data to this place, some trying to send video data, some trying to send very sensitive data, some trying to send, let us say, a doctor doing remote surgery, trying to send very sensitive to latency kind of data to the other place. Fine. And this is basically your resource. That is the path that you are getting. So if you draw an analogy, now you see that this is people, this is one point and this is the other point. And this is the divider in the middle that is there. One side there are 2 rows, another side there are 1, 2, 3, 4 rows. Fine. Now, generally from experience, if I take the, let us say, the example of Calcutta, in the center of Calcutta, the traffic coming to the center of Calcutta from the semi-urban or rural area is more in the morning, whereas the traffic coming to central Calcutta, the business district, is less in the evening, because now people are going back from work. So if I can do something to the resource that I am having, that while coming based on the traffic, I change this divider in such a way that I can use this resource optimally. So if you look at this one, then you will see that what this is doing, that it is making the one side more, the other side. So now two sides are equal, 3 lane instead. So I am basically using my resource more efficiently, isn't it? So this is what network slicing is. So this is my resource layer, that is my bandwidth and everything, and this is the network slices that I am having. So based on whether it is enhanced mobile broadband, whether it is ultra reliable low latency communication, or whether it is machine to machine type communication, massive machine to machine type communication, depending on that, I will be allocating the band. Fine. And this is where AI can help, because predicting that what will be the need. For example, let us say voice and video and augmented reality when we are talking about enhanced mobile broadband. Now, for example, let us take an example of a playground or a stadium. Now, in that area, you don't need voice and video communication high bandwidth throughout the year. Only when there is a game being played, then only there is a huge amount of people in that place. So that is the time when you need. Now, this is assisted by AI. Fine. So, if you see about enhanced mobile broadband or massive, so massive machine to machine compute is basically, or communication is basically things like smart homes, yeah, and mobile to mobile communication, smart cities, because these are machine to machine communications that are happening. Yeah. Then you have your enhanced or machine to machine is AR, VR. Yeah. Whereas ultra low latency refers to your industry automation, autonomous driving, because here latency is very critical, remote surgery, mission critical apps, for example, in case of war and things like that. The latency is a very important. So when there is a war, then only I will give to a certain bandwidth so that there is low latency. I will increase the bandwidth. Yeah. So that is what the slicing is. Now, what are the benefits of network slicing? Basically, the ultimate benefit is that, or the means in any thing, the ultimate is that there should be return on investment, that it should be profitable. Yeah, whatever we are doing. So, the benefit of your network slicing is that depending on the needs of the user, so different use cases, the single network can be used for a variety of services. So basically, based on the needs or the demand that you are using. And another is that it reduces your operation expenses and your capital expenditure, because you are basically reallocating the same resource. So that is one of the benefits. Yeah. Now next, in the dynamic slice, means dynamic AI-based network slicing. So you monitor basically the usage pattern and predict the traffic spikes and adjust the slice configuration or the bandwidth, the processing power, the parameters, other parameters, latency parameters that you are allocating to the service or to the service request. Yeah. Then you have predictive slicing, which also uses your AI. You have your enhanced quality of service through intelligent slice management. So you are basically using your, you are getting or resulting into a better quality of service. Then AI is also used for spectrum management. So dynamic spectrum allocation. So it is something similar to your network slicing also. Yeah. So you use your reinforcement learning, supervised learning models over here for your dynamic and predictive usage models. Then you have your AI driven traffic management. So based on the traffic, on the data, historical data, you predict the traffic or you demand the forecast. So these historical data need not be the data just from the communication side. It can be news articles, it can be other data available over the internet. Why I am saying so? Because in the holistic view, for example, a news article will say that today there is a game in the, let us say, in a stadium. But in the same time, the previous year there was a game, it may not be. Yeah. So these articles, and in the place, if there is a game, what will be the traffic? What will be the. So then you map all those things and you come up with this intelligent traffic management and load balancing. Now this is gives you, so you have seen ML, that is machine learning. Then you have reinforcement learning. You have federated learning. Federated learning I did not talk about. It is basically training small models at different places and then bringing them together so that the privacy is more restored, or there is more privacy. You don't share the data throughout the network. Yeah. Then you have your convolutional recurrent networks. You have your quantum ML. Yeah. Now you see, this is the role in the 6G, because I will give you the reference. You can have a look. Yeah. So you see that you can, for traffic prediction, user and behavior analysis, you can use your SVM, you can use your KNN algorithm, you can use your supervised algorithms, random forest. Yeah. For anomaly detection, you can use k-means, you can use DB scan depending on the data patterns and the complexity of the data. Yeah, you can use your LSTMs, CNNs. So this gives you an holistic in a single frame, that how you can use the different AI technologies. Yeah, to in the 6G or the 5G network. Yeah, and what are the limitations and the strengths of this model? See, for example, high dimensional and complex data. This is the strength of SVM and KNN. Yeah. So then the limitation. So it requires a large number of labeled data sets, so which you may not have. So this gives you basically an holistic view. So I do rest over here, and these are the references. This is a 2025 paper. You can have a look at the paper, and if you want, I can share the paper with Dr. Maiti and he can share it with you. This is a very, very beautiful paper. A review of 6G and AI convergence, how 6G and AI are coming together. Yeah. Enhancing communication networks with artificial intelligence. And these are the other references. So thank you very much. Over to you, Dr. Maiti.
Thank you, sir. Thank you for your very informative session. And now is the time for question answer session. Any participant, do you have any questions to Babusana sir regarding this topic? Please, you are feel free to ask. Please go on. Anybody have any question to Babusana sir? Please ask. I think, sir, nobody has any question regarding this topic.
Okay, I think either people have got the full thing, as we say. Yeah, no, that's fine. That's okay. No, thank you very much, and thank you all for attending.
Okay.
I really appreciate
Sir,
it.
sorry to interrupt you. If I am audible, can I ask you one question?
Yeah, sure. Please go ahead, Dr. Banerjee.
Sir, Sir, as you mentioned, around 2030, probably we are going to deploy 6G. So do you think we are infrastructure wise in a right position so that we can deploy 6G technically? I'm not talking about in political perspective and other things. So as of now, 5G in full-fledged, whatever the services we are getting. So is it okay in around 2020, 23, technically all spectrum usage of the 6G we can get it?
Okay. So what I can say means I'm sure you are talking from the perspective of being rolled out in India. Now, the technology is likely to be ready because we are talking about a wide band, means in the terahertz and the millimeter wave band, and we need basically before which band will be allocated for which services. That needs to be a very concrete, not understanding, a very concrete kind of people need to agree on that which band will be used for which one. So maybe by 2030, it will not be rolled out everywhere, but as a pilot or as a thing, it will be. But I think not with all the services, but it will start with step by step with different services. Yeah. Maybe in India we may not start with autonomous vehicles, and because with those services we may not have for autonomous vehicles a separate band and things like that. But for remote surgery and all this, we will be allocating separate bands and with low latency by 2030. I am pretty sure about that. So yeah, and let us see what happens. Yeah.
Yeah, thank you, sir. And one more thing, it is something different or deviated from that. Say we are using 6G, the frequency band. As of now, we are talking about the 5G frequency band and its impact to our head and something like that, or even the natural animals we are talking about. So if it comes to 6G, the amount of penetration or the penetration depth to the cell, although it is not clinically proven exactly, but still the impact is quite known if we talk about the
Yeah.
heat or the thermal zone. So if you
Yeah.
can light up on that part, sir, it will be very helpful for all
See,
of us.
see how do I tell this? Means this is something. The full thing is market driven. Now there is a balance between the damage the technology does and the market that it serves. So, so from that perspective, means it is basically a little bit of give and take or balancing act. Yeah. Do we go for combustion engines and cars and all those, or where pollution is coming? Now, we never spoke, say, 30, 40 years also before about pollution. That cars are a huge source of pollution, so we need an alternate mode. That is, we need to go to batteries and things like that, so that green cars and green. But when this has cut the threshold that the cars and polluting, then we started with the alternate. That is when the climate action and all this were becoming more serious, and the change in the climate. Yeah. So similarly, I think that in this case also, when it will reach the threshold of the damage, then we will think about something else. Yeah. So this is basically market driven thing. In all the research that is happening is market driven. Yeah.
Thank you, sir.
Thank you.
Okay, thank you, sir. Thank you, Dr. Sudipto. And is there anybody else to ask any questions to sir? Please feel free to ask. Is there anybody else? Okay, sir. I think nobody is there for us
No, it is
personally.
weekend already. It
Yes,
is,
sir.
I think,
Thank you.
8:45.
Yes,
Yeah.
sir. Thank you for your for this informative session. And we have a small greeting for you to take this session. And 1 minute, sir. Sir, this is
No, thank you
for
very
you
much.
on behalf of our college, Dr. Sudhir Chandrasur Engineering College and Sports Complex, Kolkata. And it is our privilege to have you in this session. And your informations, I think we'll try to teach our students about this topic. And I think they will enlighten themselves.
Thank you.
And thank you, sir. Thank you for your session. And uh, I'll send you this memento to your email ID. And
Yeah, no, that's appreciated.
sir, I have a small request. If you have any student level problem, any 3 to 5, any problem, can you share with us so that we can give our student about some current, they will implement it, they will try to implement it.
Means,
Is that possible, sir?
yeah, means to undergraduate or postgraduate or
Undergraduate students, sir.
okay. So, for
Sir,
example, if you get data for channel, yeah. Now in the terahertz region, means using AI, how can you do channel modeling in different conditions? Yeah, because you are going to terahertz region. So that is one of the things. Another is that combining different types of data
okay.
means not a single type of data over the time. That is, let us say combining data like combining data to predict traffic. For example, what I mean to say, for example, the traffic, as I was saying, that many a times the traffic is not stagnant on location dependence, means it varies with location. That is what happens. But as it varies with location, it varies with time also. It varies with the time of the year also. Means time not only during the day and the evening, it varies with time of the year also. So if you can bring in different data from different places, in fact, even scraping the net also, if you can bring in relevant data, combine them to predict the traffic. Yeah.
Okay.
So that is another means and using means basically in the middle using AI somewhere, means not somewhere to predict based on the historical how it happened and things like that, because the model will totally means to certain extent change. Yeah.
It is means, sir, time series forecasting you are asking for. Uh,
Time series forecasting, see in time series forecasting, if you are having only a single kind of data. Yeah, but over here you are bringing in data from different places. For example, let us say I am having the traffic information. okay, let me give you an example. I throughout the year the traffic information. Let me not talk about 5G, 6G. The throughout the year, the traffic information at Esplanade, the data is there. You can predict tomorrow's traffic information. There is no problem. But today there is a news article that tomorrow there is a protest or there is a match in the Eden Gardens. This data is not there.
Yes.
In the time series. Now you are basically modifying the data because all the data that you are having in the time series, none will be relevant. So you are using basically data from different places to predict or rather to make the time series relevant to your present scenario. Yeah. So you from the time series you are taking data and making it relevant to your present scenario based on the information you are getting from the different sources. It may be scraping social media, it may be scraping the news, it may be scraping anything. Yeah.
Okay, sir. So spatial or time series, space time.
Not space time in the true sense. I was just saying with respect to one space, but yeah.
But
Yeah.
that is predefined, not predefined. Actually, sudden data arises.
Spikes are there.
Okay. Okay, sir.
Means so that the means you the understand the dependencies and the independencies.
Okay.
No, thank you. I appreciate. And thank you everyone for attending this session. I appreciate in the late Friday evening. So can I leave now?
Yes, sir. Thank you for your session.
Okay.
And
Okay.
thank you everyone to join this session and listen to sir. And this is the end of this session 10 of our ATAL online FDP on next wave, next generation communications. And tomorrow will be the last day of this ATAL FDP online program. There will be 3 speakers, and at the end there is an examination based. You have to score above 70% in that examination, and to get the certificate. And in the next 3 sessions, it will start from 2 p.m. to 6:30 p.m. Next 6:30 to 7:30, it will be online test and feedback. And 7:30 to 8, there is a validity session. In the online test, you will give this test through ATAL portal and give your feedback about our ATAL FDP through ATAL portal also. Also, there is 3 sessions. They are very interesting sessions. 2 p.m. to 3:30 p.m. There is a session will be taken by Dr. Ankit Bhattacharya, who is the technical lead engineering and R&D services ACL technologies. He will take about the MIMO antenna design for next generation communication. The next session will also interesting from 3:30 to 5 p.m. It is session 12. The topic is quantum communication. It will be taken by Dr. Amit Kumar Dotto, sir. He is an associate professor of GS Sandal School of Telecommunication, IIT Kharagpur. And the last session, it is from the session 13 is from 5 p.m. to 6:30 p.m. on Internet of Medical Things. It will be taken by Dr. Anjan Kumar Kundu, sir. He is the Associate Professor of Department of Radio Physics and Electronics, University of Calcutta. So that's so please join from 2 p.m. onwards tomorrow. Please don't miss. Tomorrow is the last day, and we have shows the patience of the last 5 days. It will be the last day, the 6th day. So keep patience, and thank you everyone, and good night. And also one thing, please fill up the Google form given in the meeting chat by Devasmita Manna madam for today's feedback. It is, but we have a session from 2 to 8 p.m. So you may not join from 2 p.m. Okay. Okay, madam, you can join from 5 p.m. as your classes are there. So please go on from 5 p.m. And thank you, everyone. And good night for and if you fill the form, you can leave. Thank you, everyone, and good night.
Hello.
হুম হ্যাঁ শোনা যাচ্ছে অঙ্কিত is it audible to you?
Yes, yes, yes. Can you hear me?
Yes, I can
Okay.
hear you.
Okay, okay. And first, can I share my screen just to ensure that everything is okay?
Yes, yes, you can share your screen.
Okay. Okay. So here is like a PPT which I am going to share is tomorrow. So is it visible?
Okay. Yes, yes, make it full screen.
Yes. Yes. Now it is full screen. Is it okay?
No, no, enable editing. At first, do enable editing at the above. Yes, yes, it is.
Oh, okay, okay, okay. Yes, yes, yes. Sorry.
uh,
Yes, yes, yes.
Do enable editing, then go for the full screen.
Okay.
Okay, okay.
Now,
Now it is okay.
okay, okay. And yeah, I'm changing my slides. Is okay?
Yes, it's okay.
Oh, thank you.
Okay.
Then yeah, we'll talk.
Okay.
Thank you.
Hmm.